Good afternoon, everyone, and thank you for participating in today's Land Prioritization Mapping to protect drinking water quality lunchtime webinar. I am Stephanie Newmer, a water resources scientist here at the Interstate Commission on the Potomac River Basin, and I will be assisting with behind-the-scenes coordination of this webinar. Feel free to use the chat option to contact me with any questions you may have regarding technology of it. Firstly, I want to draw your attention to the poll that has been opened. Please feel free to complete this. And while I finish my tech intro, and then afterward, you'll hear the answer to the poll. Next, I would like to ask each of you to just remind you to keep your microphones muted and webcams off. After today's presenters have concluded, we will have a question and answer session. And if you would like to ask your question via audio and video during that question and answer session, please raise your hand virtually, and I or another ICPRB staff member will enable your audio and video so you're able to ask that question. Alternatively, you can also ask your questions in the chat at any time during today's presentations, and they will also be addressed during the question and answer portion. Lastly, this meeting will be recorded and will later be posted on the public ICPRB YouTube page for future viewing. If you experience any technical issues during the webinar today, please feel free to ask for assistance in the chat, and I will coordinate with you to resolve them. And with that, I would like to introduce Mike Nutter-Lilly, the Executive Director of the Interstate Commission on the Potomac River Basin.
Thank you, and welcome to everybody on this snowy time here in the DC area. I see we got 95 people on the call. That's great, shows great interest in the issue of land prioritization mapping. This event is being held as part of the implementation of the Potomac River Basin Comprehensive Water Resources Plan. That's a 15-year plan, and so we are thinking long-term here. This is the 10th in a series of webinars to learn and share information about land use practices for sustainable water resources management in the Potomac Basin. Previous webinars have been a wide range of land use issues, such as sustainable development and advances in agriculture and other sources. And the previous webinars are available for viewing on ICPRB's YouTube channel. We're excited that this event also coincides with ICPRB's 85th anniversary, and so we'll welcome anybody who's new to our particular forum. We hope you learned something new today. But the purpose of today's webinar is to focus on ways that we can protect drinking water through a land prioritization mapping tool. This latest iteration of the tool was released in October and is product of a decade of work and collaboration between ICPRB and the Potomac River Basin Drinking Water Source Protection Partnership, or what we call DWISP. Also land conservation groups, state agencies, land trusts, and other stakeholders. So we have two excellent ICPRB speakers for you here today to talk about the tool, how it can be used, and how to access the data. After the presentations, we'll open it up for Q&A to address as many questions as we can. And this event is being hosted by ICPRB with funding from our EPA Section 106 grant under the Clean Water Act. I don't see the survey up right now, but what was the vote on the survey?
It's in the chat, so you can vote in the chat. It's what % of lands are protected within within the Potomac Basin are protected. So you have a choice of 17%, 21%, 33, or 26. And we've got 22 responses so far. So I don't know if we should give the answer yet.
Why don't you give the answer?
The answer is 21%.
So and we had, how many people were successful?
9 folks out of the 23 that voted, including myself, for 21%.
Right. So anyway, thank you very much. And with that, I'll turn it over to to Renee and to Megan to take it away.
Good afternoon, everyone. Thank you so much for joining us. My name is Renee Thompson. I'm a water resources planner here at ICPRB. I'm also the coordinator of the Drinking Water Source Protection Partnership, and I'm joined by my amazing and talented GIS colleague, Megan McClottery, who is an ecological technician here at ICPRB. So we're going to be tag teaming a little bit. I'm going to start the first part of the webinar, and then Megan's going to go into some more of the technical details, as well as some real life case studies that we're going to show with you today. And then, as was mentioned, we will be available after comments, afterwards for comments. So there's our mugs, so you can see. This is just kind of interesting. We have folks from all over the Potomac watershed, as well as the nation for that matter. We have over 230 folks registered. It looks like about half of you are here today, and we have a wonderful opportunity for others who aren't able to join us to go ahead and take a look on our YouTube page afterwards. So you're welcome to share that, and everyone who received that can go ahead and everyone who's registered will get that link to our YouTube page after, so you can share that with folks. And if for some reason, if you have not finished the poll, you can just press the done button, and then that should clear out for you for anyone who is still seeing the poll. So we've got folks, a lot of folks from Virginia, Maryland, West Virginia, Pennsylvania, and DC, all part of the Potomac watershed. We also have folks from Canada, South Carolina, Maine, Colorado, Idaho, Missouri, Arkansas, all over the place. So welcome for those of you who are not familiar with our Potomac region or ICPRB. I did just want to take a moment to acclimate you a little bit to our region. So we are a 14,700 square mile watershed covering portions of Maryland, Virginia, West Virginia, Pennsylvania, and Washington, D.C. The Potomac River and its major tributaries have thousands of miles of streams that eventually feed in to the Chesapeake Bay, which is off to the right, to the east of your screen on the map there. Over 6 million folks rely on the Potomac for drinking water, making it one of the most important water sources on the East Coast and Mid-Atlantic region. And the basin includes a diverse landscape from Appalachian headwaters to fast-growing suburban corridors to, of course, the urban core of Washington, D.C., where I'm coming from now today. That's where I live. So ICPRB is short for the Interstate Commission on the Potomac River Basin. We were established in 1940 with a mission to protect and enhance the waters as related to resources in the Potomac River. We work across state lines to really focus on issues that no single jurisdiction can address alone. We also focus on water supply coordination in order to coordinate the metropolitan area's shared water supply to ensure reliable drinking water. We work on water quality and pollution reduction, where we monitor nutrient and sediment pollution and also support Chesapeake Bay TMDL goals, looking at reducing runoff and improving stream health. We have a watershed science and monitoring, where we look at stream assessments and ecological monitoring, as well as GIS analysis. And we help provide data to local governments, scientific agencies, state agencies, and watershed groups. In addition, we have some very talented folks that are here joining us today that work on public education and stewardship within our organization, that have amazing opportunities related to cleanups and workshops and walks in the woods, as well as technical assistance for watershed groups. And we also, in general, provide science-based policy and guidance for policy decisions and facilitate communication among all of the basin jurisdictions to reflect regional impact and shared priorities. So that just gives you a little bit of an idea of our organization and some of the work that we do. This is a wonderful timeline that we created recently that was sparked by discussions with our drinking water source protection folks, and it really showcases the over 10 years that our executive director, Mike Nardolilli, mentioned of the development of this data set. It started out within our DWISC work over over a decade ago, where we were really interested in prioritizing lands for protection from a drinking water source protection perspective. And it has evolved through collaborative efforts of many funders and stakeholders who have informed ICPRB's technical and participatory work. Sorry, my mouth is garbled. Folks from Adams County, Pennsylvania, Berkeley County, Cape and Lost Rivers Land Trust, DC Water, DWISP, EPA, Fairfax County, Fairfax Water, Potomac Conservancy, the Conservation Fund, the U.S. Endowment for Forestry and Communities are just a handful of many of the partners who have helped made this data set happen. So I encourage you to take a look at this when you have some time. And the link is available on our website. To start out, just to get us back into our land prioritization mapping for protecting drinking water quality, which is what we're calling this, it's really a process. The objective of this land prioritization analysis in a nutshell is to rank land parcels to protect drinking water quality and their potential to degrade long-term water quality. This product is intended for use by water suppliers, land conservation groups, state and local jurisdictions, and others that are interested in land conservation. It's anticipated from the outset that users would combine this drinking water perspective with other priorities of interest, perhaps outside of drinking water, to identify those win-win or co-benefit opportunities to achieve multiple protection objectives. And if someone wouldn't mind just placing a link to the land prioritization mapping for drinking water, the 2025 update for our website, I think that would be a great resource for folks. Thank you. So just to give you a little bit of an idea, this map shows the study area for both 2020 and 2025. So you can see in this brown area in the center, this was our original 2020 data set. And one of the key inputs that we got back from our primarily our state partners was that this is great, but wouldn't it be even better if it had full state coverage? And so we heard that, and we worked with EPA to develop a new scope of work that would encompass the full state area of Pennsylvania, West Virginia, the District of Columbia, Maryland, and Virginia. And we have plans in the future to go ahead and expand it to Delaware as well. So this gives you an idea of the real sort of scale up that we did in 2025, much to the thanks of Megan and our former GIS staff person, Andrea. Thank you, Frank. So the entire project follows a specific series of steps to identify what is protected, and then flip it. What is at risk to those areas? And then we calculate those metrics, assure that they are not correlated, or rather representing the same thing, and then summarize the results into a cumulative prioritization using parcel boundaries. This is still the approach that we're using, and we're going to walk you through the products today. So we start with first identifying those agricultural and forest land. We identify opportunities for protection. So sort of the inverse of those protected lands, we use protected lands to kind of mask out and really focus on unprotected agricultural and forest land. So we kind of start as that is our baseline. And then we identify geospatial metrics to quantify our protection priority, and we calculate the risk associated with those and evaluate correlation, and then we develop a prioritization for non-correlated metrics. So we're going to walk you through all that right now. So the first step is related to our opportunity areas, and we do use the USGS National Land Cover Data Set from 2023. So that's a 30-meter grid land cover data set. And we identify those forests and agricultural areas. And anywhere that you see in white here is essentially a mask that we've created. We've kind of erased those out because those are already protected areas. And so we really want to focus this data set on currently unprotected areas. And so that's why you wouldn't see currently protected areas like perhaps the George Washington National Forest and other protected areas in Pennsylvania there. So in this particular region, we've got about 57% forest, 20% agriculture, and then 12% developed, and then other would be sort of open or shrub scrub or water or other types of land cover not associated with those other three categories. So just for any of those techie folks out there, this is interesting to me at least. But so your forest includes those two NLCD codes 41 and 42 that represent deciduous forest as well as evergreen forest. And those areas are typically used for timber protection, wildlife habitat, watershed protection, and recreation, and are critical for maintaining ecological balance and water quality. In addition, the agricultural areas include grassland, herbaceous, pasture and hay, and cultivated crops. And generally, those lands are primarily used for food production and livestock grazing, as well as agricultural operations. Serena, if you could maybe help me just mute anyone that might inadvertently have their microphone off, that would be on. That would be very helpful. Thank you. So this slide just shows a schematic of what constitutes high and low priority ends of the spectrum for each metrics. So what is high priority and what is low priority? So all of the metrics are normalized on a scale of 0 to 100, with a value of 100 indicating the highest priority for conservation. So the purpose of normalizing these values is that so no one metric is inadvertently given more or less weight just because of the magnitude of its raw values. And this allows us to normalize the metrics so that they all have the same range of values. So we're looking at apples and apples. So for example, we have distance from waterway. The shorter distance from waterway, the higher priority it is, or distance from high quality streams. The shorter the distance from high quality streams, the higher priority it is, and so on and so forth. And we'll walk you through each of these metrics. So parcels, and this is so each of these maps that we're going to go through are the individual maps associated with each of the is it 7 or 8 metrics? Megan will answer that question. So we've got distance from waterway, which is parcels that are closer to streams and rivers are prioritized due to their high potential to impact water quality. That information is taken from the EPA Attains data set for 2024. Similarly, from EPA, the surface water source protection area for each HUC 12 is calculated and identified areas that are important for source water protection. And I do think that there is an opportunity to potentially expand this area to include state source water protection areas as well. And then we have distance from urban areas, which I think is one of our more artistic maps, turned out to be areas of urban zones that are prioritized because there's a high risk, especially on days like today, of road salt spills and runoff. And so we want to prioritize those areas that might still be agricultural and forest that are in proximity to urban areas because they're more vulnerable to pollutants. Karst transmissivity. So these are areas that allow faster transport of contaminants through them. They're much more porous and so can potentially be vulnerable if there's a high amount of karst within those areas. And it's a little hard to see on this map, but you can kind of see this spine of purple running along the West Virginia and Virginia border through the George Washington and Jefferson National Forest, as well as up into middle Pennsylvania and a little bit over into eastern Pennsylvania. We also have future land use. This is a new metric this year where we've integrated the USGS land cover projections. We went ahead and used what they call their sort of business as usual scenario. So if we're assuming that land use trends that have happened in the past will continue with those types of patterns in the future, we have some areas that are potentially vulnerable to development, and so we're giving high priority ranking. If they remain forest and ag, then we want to preserve them in the future. So we really want to preserve those areas that are projected to remain forest and agriculture moving forward. We also have high quality streams. So this is protecting existing high quality waters and prioritizing parcels that are nearby. And again, this is from our 2024 EPA Attains assessment data set. This floodplains data set is a new data set that we've also incorporated. Areas closer to floodplains received a higher priority because they're more hydrologically connected to surface waters and potentially making them vulnerable to events that may impact downstream drinking water. And really, this data set was an attempt to get at the importance of those riparian forested areas. So within those floodplains, those forested areas are close to streams and therefore important to protect for the filtration benefits that they provide. So we did do a metric correlation for this and actually found to see whether any of the metrics were effectively representing the same thing. And the idea being that the final prioritization should only include unique metrics. The table shows the correlation between all the normalized metrics, and most of the correlations values were quite low, with one exception. The most correlated metric was the distance to waterway and the distance to floodplain. And these values indicate at least a 66% of variability. So we did not remove any of the metrics based on this assessment. So at this point, I'm going to pass the baton over to Megan, and she's going to go over cumulative prioritization as well as some great information on how you might be able to use and also get a hold of this data set. So I will operate the slides for you, Megan.
All right, thank you, Renee. I feel like this slide deserves a drum roll sound effect because this is where everything starts to come together and we start seeing our results. So this layer that we're showing you is what we call the cumulative prioritization grid. And so this is the normalized cumulative result of those 7 metrics we just showed you at the 30-meter grid cell resolution. And to create this, the grid values of those 7 metrics were summed together using equal weights except for karst transmissivity, which got a weight of 0.5 since it tends to dominate the other metrics where it's present. And then those sums were normalized back to a scale of 0 to 100 as displayed here. This is a zoomed in view of the cumulative prioritization grid so that you can get a better view of what it looks like close up. The white areas, as we mentioned, are not opportunity areas. Those areas that do have color, the high priority is in purple, and in the middle is yellow, and then green is considered the lowest priority. So the cumulative grid was a great data set, but we really wanted this tool and this data set to be actionable. And so we took the 30-meter grid and rolled it up to the land parcel scale by doing 2 things. First, we added one more metric that gives higher priority to parcels that have more opportunity area within them. And then second, we applied the median value of those metrics to each parcel so that there's one uniform value across the parcels, unlike with the grid, which could potentially have parcels with a range of values within them. And initially, we had some areas that we weren't able to get parcel data for, but with this data set, those areas are filled in with the cumulative grid. That way we have a relevant, seamless data product for the entire study area with as much spatial coverage as possible. And again, here's a zoomed in view now of the cumulative prioritization at the parcel scale. And I know it's probably difficult to notice in this format, but if you toggle those layers back and forth, you'll be able to see that the parcels become uniform at that layer. I think go one more.
I think we lost our animation on that one for some reason.
Oh, okay. We should be on the one that's not bright purple.
This one?
I think one more after that.
The next one just goes to bright purple.
Oh, okay. Well, that's okay. So the last step after, it's okay. The last step after rolling up from the parcel scale was determining what we consider high priority. And so when we first produced this data set back in 2020, we had broken the data into 5 groups and considered anything over 75 high priority. This time we chose a standard classification methodology called natural breaks classification. And this method uses an algorithm to look through all of the data and sort it into 5 bins based on where there are clusters of data and where there are breaks in the data to determine where that next bin should be. And so the data are on a scale from 1 to 5, with 5 being the highest priority and 1 being the lowest. And using this method across the entire study area, anything 79 and above is considered the highest priority and ranked 5. And we have these high priority areas in bright purple to really make them stand out. And you can kind of notice that the purple is really concentrated in certain areas. And then we had these big patches of yellow and green, which are low priority. And that pattern was something that we got a lot of feedback about, since this potentially sends the message that certain areas have no high priority parcels, and that by comparing parcels on such a large spatial scale, perhaps we were masking opportunities for protection at a more local level. So what did we do to address that? We decided to reclassify the data at the county level as well. And so this map is showing the same underlying cumulative metric parcel data, but rather than classified via natural breaks across the entire study area, we have the data classified with natural breaks for each individual county. And so a parcel within a given county is now ranked on a scale of 1 to 5 relative to the range of values within that county, rather than relative to the entire study area. And this is important because a certain county might have values, for example, that range from something like 33 to 78, whereas the entire study area ranges from 0 to 99. And so if that county is ranked on a scale from 1 to 5 for the entire study area, those highest priority parcels within that county do not actually get flagged as high priority. And here we have those high priority areas again in the bright purple. And so when we take this approach, we start seeing a lot more diversity in the map, as in the purple isn't confined to certain areas, with large areas ranked as low priority. And this gives folks the opportunity to see at a much more local level within their county of interest, and based on these metrics, where the high priority parcels for drinking water protection are. Here's a summary table of the high priority acres based on these two classification approaches. We have the study area in the right column and then the county scale in the middle. And you'll notice that by reclassifying on a county by county basis makes a pretty big difference. But I again want to reiterate that we didn't change anything about the underlying cumulative parcel data. If a parcel had a cumulative value of like 48, it's a 48 in both data sets. We've only changed the scale at which we classify and rank the data. And we encourage folks who use this data set to determine what the high priority rank is based on their own thresholds. So this data set is publicly available to anyone who wants it. You can scan the QR code and it'll send us a request and I can send it your way. And we're also available to meet with folks and discuss how you might use the data set. So now we want to pivot to a quick demonstration of how someone might use this data set using the Prince William Conservation Alliance as an example. The PWCA is a nonprofit that's been advocating for smart growth in Prince William County, Virginia since 2002. And to give some folks context, especially since we have viewers from potentially all over the continent here today, Prince William County is about 25 miles west-southwest of the District of Columbia, and the primary drivers of land use change in the county are residential development as the DC metro area continues to grow, and there's ongoing demand to build more data centers in this region. The PWCA's vision for smart growth includes what they call the 3 Rs, which is reimagining what they have, reinvesting in natural resources, and redeveloping underutilized areas into mixed-use communities. And their plan also emphasizes sustainable drinking water, which is an important component that PWCA points out is often left out of the conversation about smart growth. Ashley Studholm, and Ashley, I'm sorry if I'm mispronouncing that, from Prince William Conservation Alliance, reached out to ICPRB shortly after we released our most recent land prioritization dataset because she was really excited about the alignment between these two maps. So the map on the left is the PWCA framework map. In green, they have what they call their forested belt, and then to the north, in the west, in yellow, is their agricultural and arts overlay. And then they have these two pronounced developed areas in red on either side of the forested belt. And then the ICPRB map on the right shows the high priority purple areas, which are clustered in the north, the agricultural area, and along the forested belt. And it also shows lower priority or a lack of opportunity areas in the red developed regions, which is to be expected since, as we mentioned, our data set by definition is looking to identify undeveloped and unprotected lands. And so what PWCA noticed is how our map sort of independently complements their 3R smart growth vision while ensuring that drinking water protection is part of the conversation. We wanted to take the use of our data set one step further and isolate and quantify the high priority areas for drinking water protection by land use type in Prince William County. And so to do this, I downloaded the most recent NLCD land use data set for the county, aggregated the land use types into the same categories that PWCA is using in their framework map, and found that developed is the predominant land use in the county, followed by forest and then agriculture. Next, I selected and extracted the high priority areas for drinking water protection that we had identified through our analysis for each of these land use types. And again, you'll see those high priority areas concentrated in the forested belt and then the northern part. And on this map, you can't see any high priority in the developed areas. And then lastly, I summarized the high priority areas by each land use type. So of all the forested land, about 16% was considered high priority for drinking water protection. A little over a quarter of agricultural land is high priority. And then we did pick up a tiny amount of high priority in the developed areas. So this was just one very quick example of how the data set can be used as more than just a visualization tool, but also as a way to quantify these areas that are a high priority for drinking water protection and produce meaningful results that can guide conservation decisions. So before we start taking questions, we did want to give Ashley from PWCA the opportunity to chime in and share her thoughts or anything she would like to share about her organization. I think someone is working on unmuting you.
Yes, we are. I was just...
Cool, thank you.
You should be able to unmute yourself now, Ashley.
Okay, I think that worked. Can you all hear me okay?
Yes.
All right, wonderful. Thank you so much to ICPRB and Megan and Renee and Mike. This is just incredible work. And it was so exciting to see you use your data sets and reconstruct basically what I did by looking at what we had and drawing lines on a map and looking at what our comprehensive plan was. So this is really, really terrific work and really helpful, especially since you gave a really great introduction of who we are and what we do, so I won't reiterate that. But I just want to emphasize that I really think, Prince William County is it's very strategically located in terms of the conservation effort, because in Northern Virginia, where it's located, it's the only locality within the Chesapeake Bay that spans from tidal wetlands to a mountain. So we have a lot of rich ecosystem types. We also really hold the line of urban and suburban sprawl that's radiating out from the urban core. And so we're marking that transition from, the suburbs to more rural landscapes. And then, of course, we have, 2 national parks, Marine Corps Base Quantico, and we can't be building up to those borders and expect them to function well. And then, last but not least, what's most significant to this group is the Occoquan Reservoir. 40% of the watershed of the Occoquan Reservoir is within our jurisdictional boundary. And we know that the health of the reservoir is a reflection of the health of the watershed. And like you mentioned, over the past 5 years, we have seen significant development pressure from the explosive data center industry, but also the pressure for affordable housing to continue to sprawl rather than implementing those smart growth principles that we were talking about. So that vision that you described, we really wanted to get back to, okay, well, how do we grow while also protecting our critical natural assets like our national parks, but even more critically, our drinking water. And so this was just a really great to see that coincide, I think bolsters our message, and that two organizations that are concerned about similar things came at something very similar, I think really strengthens the effort. So I just really appreciate the effort that has gone into this for the entire Potomac Basin, but it really has an impact on local grassroots efforts, conservation efforts as well.
Thank you so much, Ashley, for that context. And we really appreciate you just bringing this to our attention and letting us use it as an example to highlight our data set.
Happy to do so. Thank you, Megan.
So I think now we're going to pass it over to our Q&A moderator, Carlington. If it looks like there's a few questions in the chat already and one person has their hand raised. So we'd be happy to get through those as well.
All right, can you hear me? Yes, good morning again. Now I see questions started coming in. Yeah, they're coming in rapid now. So I think what we're gonna do is try and read through some of the questions for Megan and Renee, and then you can provide your response. If we have time, we'll open up the chat for people to to ask their questions. They may have follow-up questions and things like that. But I'll read the first couple of questions that came in. So the first one was from Gail Berringham in West Virginia. And Gail said that our organization is working with EPA on a forest and drinking water partnership in West Virginia. Would we be able to get a map showing West Virginia in more detail? The Eastern Panhandle and Southern region are of particular interest to them. So yes, if you don't mind.
Sure. Yes, we can absolutely send you the map for West Virginia. If you either scan the QR code we provided, or if you go to our website, and maybe someone can put that in the chat, you can request the data, and that will provide me with your email information, and I will send it to you directly.
Okay, awesome. And then Catherine asked, can you remind me what factors you guys use to determine the high priority categories for protecting drinking water?
Yeah, Catherine, I pulled up this slide just to give you a sense of some of the metrics and kind of how we standardize them. I wasn't sure if this answered your question or not, if you were asking specifically about the metrics that we used, or feel free to come off mute and clarify that if I didn't get that right.
Yes. Yes, Catherine, go ahead. You can unmute yourself and then ask any follow-up question to that.
Hi, no, that was all. Yep, I just wanted to get a reminder of what was included in the higher priority sections, just to make sure I understand. Thank you.
Yeah. And our website has some great information too. Heidi put our most recent direct link to our 2025 land prioritization webpage, and there's a technical memo in there, like a PDF that kind of walks you through each of the data sets similar to what you saw in the presentation today. So that's a great reference as well.
All right. And then Kate Laramie had a question. Did you use different prioritization metrics for forest versus agricultural land, given the difference in impact of these two broad categories on water quality?
The short answer is no. I'm not sure if we have some more history on that. Unfortunately, I wasn't here for the beginning of the 2022 or the 2020 project. Heidi, do you know if that's something that the early iterations discussed, and if they're, sorry to put you on the spot, I just don't know the answer to this question.
There was discussions, of course, about which metrics to select, and of all the possibilities, which would best represent the source water issues. And in the end, since that original product, they were all the same across both agricultural and forested lands.
I can add just one thing to that, that in our land use change metric, from I think whatever year we started with to 2050, if forest was going to be the 2050 land use, that got a higher priority than any sort of land use to agriculture. So hopefully that helps kind of answer it, and it kind of takes into account that concern.
Very true. Thanks for that reminder, Megan.
Adam has another question. Any plans to publish this data on a web service? I know the answer to that, but I'll let you respond. I'd like to add that this to the statewide conservation priority parcel mapping application we help maintain. So,
That's a great idea. I hope I don't answer incorrectly. So we do plan on updating a story map that we have on there currently, and we're investigating ways to have a more interactive component where you could bring that layer into view within your own project or overlay it. For now, the best way to overlay it with your existing data would be to go ahead and download the geodatabase and bring it in, and then you can see not only the priority but also individual metrics if you were interested in a specific metric within the analysis tool. So Adam, we're working on that, and we will be improving our web mapping and story map over the next year as part of our project, but it's a little to be determined on how robust that mapping platform will be.
Great. And then Carolyn asked, well, first she said, thanks for your work. How much of the study areas potable water needs are served by groundwater aquifers? We are keenly focused on raising awareness about the Piedmont aquifer and the vulnerability of the resource. Montgomery Countrywide Alliance. So I think that that question may need a little bit of clarification for everyone else's sake. So if Carlin is still here with us, can you unmute and then ask the question so that you can provide any further clarification to the group?
So thank you very much. Yeah, we are aware that a lot of attention is paid to surface water sources for potable water. And in Montgomery County, unfortunately, that is the case, and there hasn't been a lot of attention to the sole source drinking water aquifer, the Piedmont aquifer that flows from the north and probably into Loudoun County. So I'm interested in this study. Has there been a distinction made between who's served by which water source, treated surface water or groundwater? Is that part of the conversation, or is it just looking at all of the sources together? Just trying to raise awareness wherever we can.
So correct me if I'm wrong, Heidi, but I think the answer is that this particular assessment is focused on surface water and does not well take into account groundwater. I think that would be an opportunity for expansion and improvement in the future, given available funding.
Agreed. I think that's an area for improvement. Yeah. The one metric that's specifically source water protection area, I think, is dealing specifically with surface water issues. So some of the other metrics will, necessarily take into account things that are threats to groundwater supplies, but it's not sort of explicitly accounted for in any of the metrics, directly.
So I'm so sorry. I'll say one thing and then I'll turn my mic off. Thank you for that. I think a piece of information that I learned not too long ago, which I would have thought I would have known, is the interrelationship between the health of the volume of surface water and groundwater, which is to say 50 to 60% of surface water flow is derived from groundwater. So I would suggest that be, indeed an enhancement of your work. And thank you again for your work.
Thank you. Gail has another question. I believe it's a follow-up from a previous question. Can you say more about the integration between this land prioritization tool and a state's SWPP mapping tool?
And actually, if you don't, do you mind if I just jump in and add to that? Thank you. So I might not have gotten the comment. I might not have gotten what you said correct. I'm not sure if it was a source water protection plan you mentioned, but I believe you referenced how this model can overlap and interlay with a state's, it might be source water conservation. So, okay, so source water protection. So I'm still interested in if you could say more about this, and also just want to, as a side comment, as somebody who's not a GIS specialist, I don't know how to make good use of a data set if you send it to me. So I think maybe that question goes back to whether there'd be a web service available for this kind of data, but it also sounds like you are available to talk in more detail with us at some point. But this is fabulous information, and it's so timely as we're about to seek funding to protect forests specifically for the purpose of protecting drinking water. And I think we can really make a lot of use of this. Thank you.
So yes, Gail, I'll say that we welcome you to reach out to us, because one of the things we want to do is to try and get people, especially within the Potomac River Basin, to use this tool. So we want to get it out there as a to add to your toolbox. So if you think that there are aspects of this tool that you would love to learn more about, or how to use it, then feel free to reach out to us, and we'll be happy to work with you on that. So there is another question from Kate. Could you speak more to how you developed the grid prior to scaling up to this parcel level prioritization?
Sure. So the grid, you can think of that as just this collection of pixels, and all of those metrics is a collection of all those pixels, and then basically you just sum those all together. So it's all 7 metrics added together, weighted equally again, except for karst, because we noticed it had such a strong signal. So you combine all those, and now every pixel has a value associated with it. And then we used a tool to normalize that back on a scale of 0 to 100. So hopefully that answers your question, but feel free to chime in if it didn't.
Yeah, no, hi, this is Kate. I just unmuted. That mostly answered my question. Really appreciate it.
Sure.
I'm curious though, when you say pixel, were you using like a particular like scale? Like I've seen models that use the same like 30 by 30 meter grid that the land cover data sets use. I see nodding. Okay, I'll stop.
Yep, that's what it was. Exactly. Yeah, 30 by 30 meter grid. Yeah, it's just rasters. Yeah.
Okay, wonderful. Thanks so much.
Sure thing.
A question from, well, more of a comment from Frank Rogers from the Cacapen Trust. I was surprised that West Virginia had more priority acres than Maryland and Virginia. Can you review that again? So, yes. You want to make any comment on that, Renee, or Megan?
Well, I just pulled it up. This is a summary table. So at the study area level, West Virginia has 2.3 million acres. And then when we use the relative for county, it's got 2.9 million acres. Maryland is a little less, you're right. Virginia, it kind of depends if you're looking at the county or study area scale. Part of me is wondering if West Virginia has more sheer acres of forest and ag land compared to those other areas, but we'd have to investigate that further. I don't know if you have any thoughts on that, Megan.
I don't. I think it would come down to like looking at the individual metrics and just seeing how everything, again, with the land use too, played out.
Mm-hmm.
Okay.
We can get back to you on that, Frank, if you want.
There's another question from Steve. If I understand correctly, it sounds like you prioritize parcels at low risk of development under future land use. Is that right? I've typically seen the opposite. So curious to hear about the thinking on that factor. So
do you want me to take a stab at this one, Megan?
At low risk of development.
So I think I'm just trying to pull it up again. If I recall, and I'm saying this right, future land use where forest and ag are being the highest priority for conservation. So if it's currently forest and ag and it remains forest and ag in 2050, then it has a higher priority for conservation.
That's correct. Yep.
So now I'm reading your question again, Steve. Lower risk of development under future land use. So I'm going to say no, that's not quite right. It's not really focused on development. It's on whether or not it remains forest or ag, then it's a high priority. Does that answer your question?
Or if it were to be converted to forest or ag.
All right. Hearing that.
I actually had a similar question, so I hope it's okay if I jump in, but
yes, please.
Yeah, I think maybe kind of the way that I interpreted that question was if in 2050, it's the land use type is projected to stay the same. I think that I would then think that that land use was at lower risk of development versus if it was projected to change to developed or urban developed, then it would be at, I would interpret that as higher risk of development and therefore higher priority for land preservation today. Does that make sense?
Yes. I think you're right. And I would imagine that if you look at the projection for future development, it's gonna be harder to emphasize prioritizing that land for conservation, right? When you look at lands that are projected to, not undergo any development, then it will be easier then to say, okay, prioritize this parcel. And then once that is done, then it becomes more difficult in the future to undo that. And then so it's just based on my limited knowledge of, land use in the region, that's what I'll add. So I think you're correct. It's your thought process there. So another question from Laura O'Donnell. Did you consider land ownership types, whether private or public, when determining prioritization metrics? yeah, it would be interesting to overlap that information.
I mean, the short answer is no. We used the parcel boundaries, but we didn't use any information associated with those parcel boundaries, whether it be, you know, ownership or any, you know, zoning or any information like that. We just simply used the parcel boundaries, and that was a bit of a limitation as in order to use the parcel boundaries, we could only use the boundaries and none of the identifying information. But I think if you were to, for example, overlay those priority parcels within the high priority areas, and then you as an organization, say a land trust who might be interested in conservation, you know, could potentially get your local parcel boundaries and, you know, start looking at opportunities based on ownership type. I think that would be a very valuable use case or an example of how one might be able to utilize this information in conjunction with more local level parcel scale information, depending upon your organization's interests.
Great. I think we're almost at time. We have time for maybe one more question. And I see a question from Sylvia, ma'am. And if you're still on the call, would you mind unmuting yourself and ask the question? Because I believe you have a follow-up question as well.
Hi, thank you. Yes, I'm going to have to go back and remember what my questions were. But first question, I think, was, did you include the GIS layer from NRCS, which would be available for each state for the priority source water areas selected under the Farm Bill?
So I think that's another area of opportunity, especially after that call yesterday, was an area that I had gone so far as to start looking at that data. And I think that there's an opportunity there to overlay this, not only the state source water protection areas, but to potentially the NRCS source water protection areas. And currently we're just using the EPA source water protection areas. So if we were to expand, you know, this map to include NRCS and state, then potentially we have a larger proportion of percent HUC within a source water protection area, for example. And I think that that is potentially an opportunity, but you know, for the future for us to improve this data set. But on the short term, I think overlaying it with those other source water protection area data sets and looking for the priority areas where they overlap could be a low-hanging fruit for any jurisdiction or locality. And we'd be happy to work with folks if they were interested in doing that.
Yeah, absolutely. I mean, I would say you should be able to get the NRCS data layer fairly easily. It's publicly available. It's not sensitive the way a state source water protection area data set would be. And it would mean that for owners of private forested lands or ag lands or rangelands, they could get up to 90%. Actually, in Virginia, it would be 90% cost share or reimbursement for installation of practices. So that would be right in line with your objectives. And the second question was more a follow-up for the Prince William County person, because the discussion about smart growth, I'm just wondering if Smart Growth America, who used to focus more on water, but lately seems to be more on transportation, if there are resources available from Smart Growth America for communities interested in developing their comprehensive plan or other tools to address this issue, which I think is really critical. And I haven't looked at their website, and I was wondering if the person from Prince William County knew if there were national or more broad resources.
I haven't looked into it either, so thank you for flagging that for me.
Thanks. I'm going to put my email in the chat, and I would love to talk to you further about that.
Oh, terrific. Thank you.
And thank you, guys. This was great.
Great. So I think Sylvia saved us 1 minute. So I'm going to give that minute to Jared. Jared Beard. If you don't mind unmuting yourself and asking your question.
Hi, I just typed in there just real quick. I've been reading up on the karst transmissivity, and I'm just curious about the significance of that versus karst accessibility to contamination versus its transmissivity. The reason I ask is we recently had a layer developed by West Virginia University to map karst features across West Virginia. We had about 90,000 karst features that were identified, and just their presence, can define a density of sinkholes, depressions, things like that, that would indicate a susceptibility to contamination, which would be independent of transmissivity if it's never contaminated, or if they're not accessible to contamination. So I'm just curious about that concept versus what you've used.
So, do you want to go, Heidi? Go.
I was just going to mention that one limitation of sort of all of the metrics is finding something that would represent the concern where we had data across the entire study area. So it sounds like you have a great layer and data set in West Virginia, and I'd be super interested to look at it. But we found that the transmissivity layer was what we had available for the entire study area. So that was sort of one limitation that we were facing.
Understandable. Thank you.
All right. So I'm going to do the closing comments, but feel free to shoot any questions you have over, to us. This webinar is being recorded. So if you want your question to be on the record, us ICPRB folks will hang on a little bit longer, a few minutes, to answer your question, but we want to be respectful of everyone's time. So again, I want to thank everyone for participating in this lunchtime webinar. And so look forward to a follow-up email from us. And we hope to see you guys at future seminars as well. Thank you. So yeah, if you want to stick around and ask more questions, we will hang on for a few more minutes. So the floor is open. Thank you.
I had a question. How did y'all, I came a bit late to the webinar, but I just wanted to know, like, how did you weight different things? Like in terms of, did you run a regression model or, to determine that the karst was like very highly weighted over the rest of things? I don't know if that makes sense or.
Yes, absolutely does. So is Megan still on?
I am, but I'm not sure because unfortunately that was done by Andrea, a predecessor, and so I'm not sure how we came to figure out that karst had such a strong signal. I'm just aware that we discovered that and weighted it differently when we combined them.
I can try to chime in, Megan. I think it's not as sophisticated as maybe the question would have indicated. So when the original land prioritization was developed and the cumulative grid was put together, basically what you saw was the karst map. So it kind of took over everything. And that was the only one of all of these concerns that potentially, are concerns for source water protection and downstream drinking water quality. you're just seeing the karst layer. And so we basically just tried to tone that down and brought it down to half, so a weight of 0.5, which then allowed the patterns and the other metrics to come forward. So there wasn't really a statistical analysis that was done. It was more of a visual interpretation of where do we start to see all of the different metrics sort of shining through, and not just the signal of the karst layer. Hope
Okay,
that helps.
yeah, that definitely helps to understand like what the prioritization mapping is. So yeah, thank you for that.
Yeah, and thanks for
Thank
your
you for this
question.
presentation as well. I hope to, take a look at the recording and email you guys with any questions. Yeah. So thank you.
Thank you.
All right, have a great weekend.
All right, guys. I think we've come to the end. Yeah. So see you all at the next webinar. Bye.